Good morning to all the participants. Department of EEE, the Oxford College of Engineering welcomes you all for the 1 week FDP program on recent trends in electrical engineering, day 5, session 9 on MEMS devices in real-world applications by Dr. Basudeba Behera, Assistant Professor, IIT Guwahati. I now request Professor Anup HK to deliver the welcome speech.
Good morning, one and all. On behalf of the President of Children's Education Society and Chairman of Oxford Educational Institutions, Management, Directors, Principal, HOD, staff, and students of the Oxford College of Engineering, I, Anup HK, Assistant Professor of EEE Department, to deem it a great pleasure and privilege in welcoming you all to the first session of Day 5 Faculty Development Program on recent trends in electrical engineering, hosted by EEE Department in association with IST Students Chapter. And it is my pleasure, Department of Electronics and Communication Engineering, and Associate Dean, Faculty Welfare, National Institute of Technology, Jamshedpur, share his knowledge. Today's topic for the event is MEMS devices in real world applications. So Dr. Basudeba Behera sir has obtained his BE degree in Bachelor of Engineering in Electronics and Instrumentation Engineering, GIET University, Gunapur, Odisha. He obtained his MTech in Electronics and Communication Engineering, GIET University, Gunapur, Odisha. MHRD, Government of India sponsored a scholarship for the MTech program from August 2007 to June 2009, and he obtained his PhD in the area of modeling, simulation, and fabrication of surface acoustic wave motors employing fuel friction drive in Indian Institute of Technology, Guwahati, IITG, with the scholarship of MHRD, Government of India, from July 2010 to June 2015. Dr. Behera sir has worked as graduate engineering trainee at Time Technoplast Limited, Daman, India from 2006 to 2007. Sir has joined as Senior Research Fellow at Center for Nanotechnology, IIT Guwahati from 2015 to 16. He worked as Assistant Professor at Indian Institute of Information Technology, Dharwad from 2016 to 2018. Currently, he is working as Assistant Professor at National Institute of Technology, NIT Jamshedpur. His areas of research interest includes micro or nano electromechanical systems, MEMS, piezoelectric devices, sensors, actuators, surface acoustic wave devices, Internet of Things, IoT. He has published over 22 technical papers in international and national journals and conferences. He has guided many innovative projects by UG, PG, and PhD scholars, and he is guiding. And as his achievements are, Dr. B. Behera sir has qualified graduate aptitude test 8 2007 and All India rank 962 in instrumentation engineering. And he has qualified Isha JEE with the rank of 339 2002. Has two patents titled Dual Drive Surface Acoustic Wave Motor and the package. And second one is Dual Drive Surface Acoustic Wave Linear Motor and the package. Sir has authored 4 chapters in literature. Dr. Behera sir has authored 4 proceedings in Scopus. Sir has submitted 4 project proposals and one is ongoing project with a budget of 3 lakh rupees. He has invited for many technical talks. He is a lifetime member of Indian Society for Technical Education, ISTE, a senior member. Once again, it's my pleasure to welcome Dr. Basudeba Behera sir on behalf of management, directors, principal, HOD, faculty members, and students of AAA department. Now I request our HOD Dr. Bharat Yes sir to brief to discuss about today's event. Thank you.
Thank you, Anup sir. Thank you, Anup sir. Thank you very much. Very good morning to very good morning all of you. So, behalf of Children's Education Society President, Director, Principal, and all the participants, students, and faculty coordinator, behalf of everyone, I welcome Basudeba Behera sir to this 6 days FDP program. So very thank you very much for your great support as sir. With your busy schedule, you accepted our invitation and you are supporting and encouraging to do such an activity in a Oxford College of Engineering. Really, we are very much thankful to your great support, sir. So your area is as a emerging trends in automation, electric vehicles in all the field. So definitely, I feel your expertise, knowledge will be very much helpful to our students, participants, and faculty team. So thank you very much, sir, for accepting our invitation and delivering your experience to us. So once again, behalf of everyone, I thank you very much for your great support, sir. Thank you very much, sir.
Thank you, sir. Thank you for the nice and beautiful introduction for me.
Thank
Okay,
you, sir.
so without any late, I will start my PPT presenting. Okay,
Yes, sir.
so yeah. Hopefully now it is visible. It's
Yes, sir.
visible.
Your slides are visible, sir.
Okay. Okay, so I will start presenting this thing. MEMS
Yes, sir. You
devices
can
in
start, sir. Yes,
yes,
sir.
yes.
Start.
So, so now today I'm going to present about the microelectromechanical system devices in real world application. So basically how it is relevant with the current FDP which is going on. So basically this MEMS is nothing but it is not dedicated to any specific branch. It is mix of your electronics, electrical, mechanical. In nowadays it is nothing but biotechnology, biology. Those things also added in this devices thing. So if you will go through this today's lecture, then you will find that there will be a huge scope for going for the research thing in this area. So basically I will be going through the introduction part of this thing, MEMS and various type of your actuators like electrostatic, thermal, magnetic, safe memory alloy, piezoelectric. These are the various type of your actuation things are there. And specifically I will be going for this piezoelectric actuation thing, okay, because my special I'm very much interested and inclined to this type of actuation thing, and I'm doing research in this area also. Even my current students, they are also working in this piezoelectric actuation things. What is this MEMS or the microelectromechanical system? If you will see in this picture or if this figure, this is mix of so many things are there. It is mix of your IC, mix of sensors, actuators, and micro machines. Now if you will come to this one inside of this circle, then you will find it is nothing but consist of your electronics or electrical components with your mechanical component at micro level dimension. That means it is not from the top to bottom, but if you will see these components, but it is mixed at the micro level. What is this thing? What is the micro level? All of us knows this meter things, okay, centimeter, millimeter, micrometer, okay. So now, but still I want to introduce this thing because saying in words or saying something like yes, this is centimeter, it is fine, we can able to think or we can able to visualize. But when it is coming to lesser, like millimeter, then it is coming to micrometer, then it is coming to nanometer. In that time, you are going to get the visualization difficulty. What is the visualization difficulty? See, the micro is nothing but 10 to the power minus 6 meter. But how you will visualize? Then you should take for an example, like suppose you will take the dimension of your or the width of your hair, the human hair, and with that you can able to predict how much it will be. So for the introduction of this thing, it is nothing but the MEMS is the combination of your microsensors and or the microactuators at and your electronic devices at your micro level dimension thing. Whatever I am saying, like how you are going to predict or how you are going to visualize how much is that the micrometer, if I am saying how much it is. So for that I have given one example. The width of a single human hair ranges from your 20 to 200 micrometer. Now you can think of, if I will say like 1 micrometer means, if I will take at the lower end of the human hair size, then it is nothing but 1 by 20th time of your a single human hair width. That is nothing but the micro level dimension. Now what is that? After this at the micro level we are designing the devices, either it is sensor thing or it is the actuator thing. Those things we are designing at this micro level thing. So the what are the products available in this case? Then there are some microsensors are there. In microsensor there are various type of your how it is working, what the working principle. With the working principle, it is categorized into acoustic wave, biomedical, chemical type of inertia, optical, pressure, radiation, thermal, so many things are there. But in nowadays it is very much the trendy thing is nothing with the biomedical things. Even in today's world, what are the pandemic it is going on, in this case even the governments or so many other organizations are, they are talking about this the sensors or MEMS devices included with the biomedical, so that they can able to detect what is the the COVID-19 virus things. If we want to detect, then biomedical things we will be added with the this microsensors, and that will be a small device, and immediately it can able to detect whether the person is affected with the COVID-19 virus or not. So that's why this is the trendy thing. So now if you will see the biomedical with the electronics, it is going to it is going to give you a very good result. So just like that, there are micro actuators are there. In this case, the valves are there, micro valves are there, micro pumps are there, even the microfluidic things are there, electrical and optical relay switches are there, grippers are there, tweezers, and the tongs. What is this tongs? Tongs are nothing but it is type of your just like if you are keeping something and we are just like a micro level of your actuation thing will be there. If we are giving some excitation to this one, then it is going to make the displacement. Okay, even this tongue thing, it can come under this microsensors. What is the thing? Nowadays there is a thing is there that is called the smart tongue. Smart tongue it is saying. So what is that? In this case, so if you will say wherever the tea leaf production is going on, just like in northeast India, there the tea leaf production used to be there. So here only I am going to put one example for this. Some time back, there is some quintals of tea leaves that is exported to USA, and during in that thing, what happened? They have some, when they are importing that thing or at the import place in USA, they used to test that tea leaf how much chemical it is containing. So they have some threshold value, just like something like your 20% of the chemical should be 20% of the chemical which is given for the production of this tea leaves, that is fine. If it is more than that, then it is going to be, they are going to reject that thing. So some quintals of tea leaves sent from India, it reached to USA. There they started testing the tea leaves, and they failed to come under this 20% of the chemical container, the chemical composition thing. So in that case, what they did is everything they rejected. So the cost which is involving to export from here to there, again bringing back, that will be too much costly for that company. That's why they dumped everything in the ocean. So what is that this smart tongue will play the role? Now this will be one type of device will be there. In this case, smart device will be there, sensor will be there. So here one opening will be there, and you just take some tea leaf thing, and just place here with some liquid. Immediately it will show you that yes, this much of chemical thing is involved in this production of this thing. So that means immediately it is going to say you that whether it is that will be allowed in other countries or not. Okay, so that is the nothing but the smart tongue thing is there. So other micro device components are also there, like pumped up reconnaissance aircrafts, mini robots, toys, microsurgical thing. What is that microsurgical? Even if you will go to any dentist, so there whatever the grinding machine will be there, in that case the motor what they are using, that is also made of this thing, this micro actuator things. So just like that, mobile telecom equipments, in mobile telecom, where it is coming, it is your resonators, the signal which is it is transmitting, or it is receiving, or it is nothing but cancelling the noises. In those cases, this MEMS devices it is used. Now, before going to the research area or everything, we should know that what is the what is the revenue it is generating. Then only we should go, because if someone is doing some research or some teaching or some production of some devices, then that should give them some profit. If it is not giving any profit, then why one will be motivated to go for that thing. So if you will see, the global MEMS market size was valued at $48.74 billion in 2018, and it is projected that it is going to reach around 123 US dollar, like billion US dollar thing, by 2026. So that means it is a trendy thing. That means if you are going to put your hand in this case, then you will not be in loss. Definitely you will be in profit only. See, till now in India also there are, if you will see that the MEMS fabrication lab are very less. Less means in terms of resource only, it is research only it is available, just like your IISc Bangalore or IIT Bombay, but it is little bit older one, and now it is coming up in IIT Guwahati also. In IIT Guwahati they set up that thing, but in terms of commercially, like as per my knowledge, I think in IISc Bangalore only they used to provide some of the other companies to do the production for their company thing. Okay, and that is also is a dedicated slot. It's not 24 hours. So if in India also the fab labs will be installed or the fab labs will come up, then we are also going to generate these many the revenues. So there is enormous opportunity in the manufacturing industry. Okay. Now, what type means, if I will come to this one, there are some segmentations are there, global MEMS market segmentation. This may be depending on the type, application, region, those things it is there. So if I will come to the type thing, it is nothing but the sensors. So in sensors, basically inertial sensors are there, pressure sensors, optical sensors, environment sensors, ultrasonic. So I will come with the one of each, for each of them I will come with the examples. So now in actuator case also there are optical MEMS is there, and nowadays it is called the MEMS, that is micro optical electromechanical systems. Okay, that is MEMS. And the microfluidics, this is radio frequency MEMS, RF MEMS. And then other actuator also there, just like your micro speakers, ultrasonic fingerprints, those things are there. Now, if in terms of your application thing, how it is this MEMS market is divided, that is your consumer electronics, under automotive. See, this automotive thing, this is now, because see, if you will see, so many companies they started that auto driving cars, means automatic driving cars. That means no driver is needed. The if you just put the place thing, like from where you are going, just like from to, and in that case it will find the path and it will go there. For that it will treat just like a human being is only riding that car or the vehicle. For that, just like a human being is having so many sensors and so many motion this lamps, so in like that only that will be treated. So for that, it is this MEMS devices are very much necessary. Industrial, aerospace and defense, healthcare, telecommunication, so many applications will be there. And by region, but if you will see, like throughout the world, they are using this thing, from your mobile to your smart watches, or what are the smart devices you are using either in your home or smart appliances, everywhere it is using, and throughout the world they are using. But still there are some regions who are consuming a lot. That means if you will see those areas, the revenue will be generated high. So like just like your North America, US, Canada, Mexico, in Europe, UK, Germany, France, Italy and rest of Europe, they are also using this thing, and in Asia Pacific highly demanded, and even the China is producing these MEMS devices a lot. Even the Japan, they are also contributing a lot in the innovation of innovating so many these MEMS devices. Now India is also there, who is in consuming stage, like we are consuming a lot, and some of the researchers, they are also working for development of so many devices. If you will see, if you will just visit the IISc Bangalore website, you will see every day they are producing some new devices. Okay, South Korea, rest of Asia Pacific. So like that, the regions it is divided. So the same thing it is only in global, how it is the MEMS devices divided. If you will see, there is your smart consumer electronics it is used, then emerging trends in automotive industries. Already I told this thing. Now this one is very much necessary. If you will see in my research areas, that I am adding this IoT to my checklist. Why I am using this thing IoT? Because the Internet of Things, it is also requiring this MEMS devices at the nodes. So if you will go to market and you have some knowledge about this IoT, then definitely if you are a student or if you are faculty or if you are a researcher, then definitely you have a something different value, like additional value for you. Okay, why? Because this is the trendy thing everywhere. Whatever the things you are using, in this case simple, you will be using some internet thing for the connectivity and collecting some information, and according to that, if you are utilizing that data for application of for some solution thing, then definitely you are going to be valued person in that case. So in this case, if you will see, there is a lack of standardized fabrication process of MEMS. So what is the meaning of this thing? This thing will also will come to this one. What is that? If you will see in integrated chips or the IC things, okay. So what is that in IC thing? Everything, just like if you want to design a memory of this thing, then you will be having a proper standardized fabrication process. Like suppose there are 5 processes are there, you are going to that follow that 5 process only to fabricate that thing. But in MEMS thing, there is no standard thing. That means whatever the idea you will give or whatever the innovation things you will give, people are there to accept you if it is a reliable one. Now why I have shown you this thing, this why? Because I told you this MEMS is nothing but the multidisciplinary. It is not based on any electronics things or any mechanical thing. It is made up of, if you will see, there are natural sciences like physics is involved, biochemistry is involved. Under this thing, it is coming to electrochemical processes, and in electrochemical processes, it is also made up of your electrical engineering. I told you how it is beneficial for you. Like in electrical engineering, what we need from the electrical engineering to the designing of this MEMS devices, in this case we need to optimize the power supply. How you will provide the power supply that with the less amount of power supply and you are able to function a lot, like more than sufficient thing you are going to generate out of the small power. Then electric systems for electrohydrodynamic and signal transduction, electric circuit design, integration of MEMS and CMOS. Just like that, in under this quantum physics, if you are coming solid state physics scaling, then in this case it is coming on as the mechanical engineering. From the mechanical, we need the machine component designs, precision machine design, mechanism, linkage, those things. Like that, chemical engineering is there, metal engineering there, industrial engineering. Even here I will add another thing, the biotechnology thing, the bio thing. In bio case also we require a lot for this bio is needed to integrate to get the this various sensor of the present demand. Okay, so what is the major commercial device? What is the major commercial success? The success is nothing but the pressure sensors and the inertia sensor. They are the at the initial stage of this MEMS devices, these things were made and they produced a commercial success thing like airbag inertia sensors was at so this thing airbag inertia sensors they are producing 2 billion units per year. And it is going to increase in many fold. Why it is going to increase? Because if you will see in India there is, if you know that BS1, BS2, BS3, okay, BS4, now BS6 is going on. What is that? Bharat standard, or in that case they are saying that the government is giving the guidelines that if you are designing some car, there should be the safety procedure high, like that should be the airbag safety balance will be involved in that car. So initially they said that okay, if you have, if the driver is only having the airbag safety thing, then it is fine. After that they said that okay, the driver along with the the passenger who is sitting beside, so these two things having the safety, that then only the cars will be allowed to produce. Now they are saying that no, whoever the passengers are there, suppose in a car there is 5-seater car is there, so driver, then a co-passenger, and besides suppose 3 passengers are there, then for everyone there should be safety balance should be there. In any case, if it is meeting with any accident, then it is going to save the passengers and the driver. So in recent market dynamic, so like old MEMS thing, pressure sensor, accelerometer and other MEMS were there, but in new thing we record the bio MEMS, then IT MEMS for telecommunication, opto MEMS, that is your MOEMS, okay, and RF MEMS thing. Okay, so this is some of history thing is there, but I will leave this thing, Okay, this is something I will come area of research, some optical MEMS. Why I am leaving this thing? Because I am going to show you some of the applications which will be of interesting. Okay, before that, this optical MEMS, I will come to this one. So in this case, this is a monolithic integration of mechanics, electronics and optics. Okay, in here I will provide one of the example. So one of the person I know, he was the undergraduate student at Guwahati. He is continuing his masters and PhD at UCLA, USA. So there he has developed one optical MEMS thing. So what is that? That MEMS device will be attached inside your eye, okay, and that device is continuously detecting your sugar level. So there are some mechanics are there through which it is taking that liquid and continuously it is detecting, okay, whether so with that he has got some USA patent also, okay. So that is the type of thing it is coming up in the optical MEMS. Even so many other things also there, just I have given one of the example. Then bio MEMS, miniaturization like minimal invasion and size match with the biological entities. See, I feel I will come to this biomems. I told you already, for detection. For detection means for detection your COVID-19 virus. What we will do? I think in Japan or somewhere they have developed that device now. Just look to me. So if this is the mask I am wearing, and with the mask only, if I will attach the biomems thing, if I will attach the biomems device to this thing, so what it will be done? What are the the breathing I am doing in that case? From that thing, it is detect that that device will be attached with the mask, and what are the virus, if it is there, then it is going to be deposited in the sensor, and that device will be connected with your mobile, just like you in IoT thing. And if it is just like we have seen, no, like how many times with the rotation it is going to detect that thing. So just like if the quantity is less or high, then it is going to show you the it will give you that message that yes, it is detecting in your breath. I think you are affected with the COVID-19, or you are safe thing. Okay, just like that, it is, they have already developed that thing. Okay, so I don't know whether they are coming with the application thing or not, but they have developed. I have seen this one in recent news. Microfluidic laboratory on a chip or micro total analysis system thing, that is the reduced amount of samples and reagent and associate costing. Okay, fine. Now RF MEMS, this one is very much necessary for what are the mobile things. In this case also we used to use this RF MEMS thing for the signal communication thing. So in MEMS also, if you will go another step ahead, then it is coming to the nano electromechanical system, that is of your 10 to the power minus 9 meter. So what is the 10 to the minus 9 meter? That means, so just a minute, I will, so 1 minute I will. Okay, so now in nano electromechanical system, that is 10 to the power minus 9, it is going ahead thing. So okay, these are the sensors, actuators. There are so many domains it will be involved, just like already I have shown you that multidisciplinary thing, just like radioactive, magnetic, chemical, mechanical, thermal, electrical, those things are involved. Okay, just I am coming to one of the example of this microprocessor sensor. So in this case, how it is going to work, how it is going to show you the working thing. Just like there will be the input signal will be there, and there will be output signal. Like input signal means if I am giving some pressure, just like here, if I am giving some pressure to this thing, okay, it will show you how much Newton of your pressure you are providing. Now that is the input thing, and how much it is showing, that is the output thing. But in that case where the micro sensor it is coming, there this is the micro sensing element it is coming. So think of that, this is a pressure sensor is there, na? So in pressure sensor also it is a capacitive type. Capacity means everyone, if you are belonging to the electronics or electrical thing, you know the what is the principle of this capacitor thing. So now just like that, in this case, if I am saying that this plate is fixed one, this plate is fixed one, and this is movable one. So now if I am giving some pressure and this plate is deflecting towards the fixed one, or it is going away from the fixed one, then it is going to give you some value thing, some electrical value. So what it will do out of that, so this is the physical thing it has done. Now in this case also, this is the mechanical type of thing. Out of that, it should be converted into some of the electrical type of thing. So for that we require this transducer unit. Okay, and this transducer unit also needs some power supply. So this will be the whole assembly for your micro pressure sensor thing. Okay, so what are the considerations? Means if I am looking for a sensor, then what are the parameters I am looking for? See, I am going from the very basic, and immediately I will enter into the application stage. So in the sensor thing, if I am saying, that should be it is falling on the physical sensors, the chemical or biological sensors, and under the physical sensor there will be force, acceleration, pressure, temperature, flow rate, acoustic vibration, magnetic, everything will be there. In chemical also, concentration of chemical, pH value, binding strength, protein, those things will be there. When we are coming for the sensor design, what are the parameters we are going to make in our checklist? So, there should be sensitivity, how much sensitivity is there, linearity, accuracy, precision, responsivity or the resolution, noise, dynamic range, bandwidth, drift, sensor reliability. So, this should be in the checklist. That means, if it is satisfying these all things, then only your sensor will be the very successful commercial device in the market. So, just like that sensor, there is actuator or the micro actuator I am saying. In this case, simple, I am providing so in previous one, if you will see, there is input signal you are providing from the outside and output signal you are just looking to that one how much it is generating. For that, we are designing this micro sensing element along with one transducer unit is there. But in case of your actuator, what is the difference is there? Simple, if we will provide some power supply, okay. So, in that case, it requires some amount of your it need to be activated with some excitation. Na? So, what type of excitation it is taking, whether it is taking the either it is the type of your wave, it is type of your signal, or it is directly electrical thing. For that, we need the transition unit thing. So, in this case, directly it is going to give you the output action, like actuator is there. So, if you will see, simple, you will connect this one also, it is also okay, no problem with that thing, provided if this actuator is recording only the electrical power thing. Suppose in terms of some other waves, suppose from electrical, then it is coming to some wave type of thing, some frequency type of thing, then this one is activating this actuator, then in that case only we record this transition unit thing. So, if you will see, this is nothing but your a micro rotor thing, these are the starters, are there. So, this one is nothing but rotating, this is nothing but rotating thing. Okay. So, this is nothing but the micromotor produced by the Liga process. So, just like sensor consideration, in case of your actuator consideration also, we require the checklist, that is your torque, force output capacity, range of motion, dynamic response speed and bandwidth, ease of fabrication and availability of materials, power consumption and energy efficiency, linearity of displacement as a function of driving bias, that means how much it is displacing that thing linearly, cross sensitivity, and then footprint. This footprint is it is necessary for both sensor and actuator. What is the meaning of this footprint? Just I am discussing this one. That means how much area it is taking in your complete device. Think of that, my total device is this much. Okay. In that case, how much this is taking, how much space it is taking. Okay. So, in this case, if this is my total device, this is the total device size, then in that case, what are the sensor I am using or what are the actuator I am using, how much area it is taking, that is nothing but the footprint. Okay. So, this is the microsystem thing. Okay. This is a complete package like sensor, actuator, everything it will be added. Now, these are the applications. Now, here onwards you will be getting the interesting things. I was talking about this the micro inertia sensors, or if I am using some airbag, if I am using some safety air balloons, then how it is activated? How it is activated? That means if this is the obstacle, is there, okay, and this is my vehicle, it is coming, and when it is hitting this thing, okay, that time here I am putting the acceleration, the micro inertia sensor thing, just like placed here. This is the actual picture it has taken. And if you will see, this is the device inside this one, this is the device only. Here, this is one type of a COM type of structure. COM type of structure means you all of you know the COM thing. Okay, so in this COM, there will be a vertical COM will be there, and a horizontal comb will be there. So, in this case this is nothing but your fixed one, and this one is nothing but moving one. When it is because of some jerk or some obstacle it is meeting, at that time this movable one it is going to close to this one. With that there will be some capacitance variations will be there. If the capacitance variation is more than the required thing, just like if it is something I am saying that 2, I am saying that one value, I am saying that it should not be more than 2 in terms of a standard 10. Okay, if it is going beyond that 2 thing, then it is going to open that air balloon through the nitrogen gas thing. So here the crash is there, in this here it is the crash is there, with this it is reaching something 5 points like something it is reaching. With that it is immediately giving the inflator to open send the nitrogen gas. With that it is opening the airbag thing. So with this it is nothing but saving the driver or the co-passenger thing. Okay, if you will see the interesting things are there, like this is the rice grain is there, this is rice grain is there. So these cars they are well functional means they are movable cars, it is not a dummy one. And I am not saying about the machines, but the wheels it will be working. Okay, some parts it is working, but it can be able to move, it can able to move. So that type of things they have produced. Okay, in digital computer also the miniaturization. See, if you will see ENIAC, our first computer in 1946, and now you are having the laptop or the mobiles. This is also not less than a small laptop thing. Okay, this one also able to process all the type of your data, those things. So this is the power of this miniaturization thing. Okay, okay, market demand. Okay, fine, these things are fine. I am coming to application of the thing. Automotive industry, aerospace, biomedical, consumer products, telecommunication industry. Okay, in automotive industry, so we for what purpose we record? For the safety, engine and powertrain, comfort and convenience, and vehicle diagnostics and health monitoring, telematics. Those things are there. If you will see, if you will check for a vehicle or a car, how many sensors there in a basic or the basic sensors only, if you will see, it's around 10 sensor it has shown. But nowadays if you are going for the higher end cars, just like Mercedes, BMW, so in those cars they are using, it's a pack of the sensors and actuators, MEMS, micro sensors and actuators are there. If I see I'm just naming those 10 sensors. It's a temperature or the manifold or temperature manifold, absolute pressure sensor. Here this is the thing. Then exhaust gas differential pressure sensor, where it is this one. Then fuel rail pressure sensor, where it is here. Then it is barometric absolute pressure sensor here. Then your combustion sensor, gasoline direct injection pressure sensor, fuel tank exhaust fuel pressure sensor, engine oil sensor, transmission sensor, tire sensor. See, I will say you that even nowadays in basic cars also you will be finding whether when you are parking your vehicle, that time your tire is that tire position it is showing you that whether it is properly parked or not. With that also they are taking cameras as well as some sensor part also, so that if it is parked in the straight then it is fine. If it is little bit angle thing is there or little bit inclined thing is there, then in that case it will give you that no, your car is not parked properly. So that case it is requiring the sensor thing. In telecommunication industry there are optical switching and fiber optic couplings, RF relay switches and tunable resonators are there. Now it is coming to the actuator part. So I'm just the mix of sensor and actuator I was saying. Now I'm coming to the mainly actuation of this thing. In this case you are having this electrostatic, thermal, magnetic, piezoelectric thing. I'm coming to the electrostatic. The GI picture is there. Okay, so this electrostatic is nothing but it's type of your like attractive and repulsive force is there. Okay, so with that means suppose I'm keeping one plate fixed or fixed electrode is there and another is your moving electrode is there. In this case if I am providing some voltage to this thing, that time it is coming close or going up. In this case this can be used as the actuator. How it is going to be used as actuator, just see. just like your cantilever things. Okay, if I want to displace something, if I want to, so this is the main beam is there, this is main beam is there. If I want to make it activated and I want to push it something, so think of that, this is in terms of your some micrometer is there, and whenever some object it is coming, I want to push it, that time it is nothing but the excitation will be given here and it is going to make it pushing this thing with the bending thing. Or I have already given you one of the example in terms of your pressure sensor thing. So what is that thing? Like here the air gap will be there, this is your capacitive type of pressure sensor. So this is under coming the electrostatic actuation thing. What is that thing? If I am providing this energy excitation to this one, that time this one will be fixed one, and with the bending thing it is going to give you some difference of your this the capacitance. With that it is going to try, with that it is going to give you some value where it will decide whether it is crossing the threshold or not. Just like the gap distance between the electrodes is small near the clamp heads and the beam is increased with the position along the length of beam. So if I am applying some voltage, the electrostatic force is created that deforms the beam along the outline of the electrode thing. So just like that, if we will see another electrostatic example, this one, the COM drive, which is also used in the inertia sensors. In this case, I already shown you one picture, no? So that is your, this one you are putting fixed one, and this one will be movable one. So what happen? If you will see these sides, these are treated as one of the plates, and the different sides of this movable one, they are also treated as some plate thing. So with this, if it is going up, means going inside or coming outside, with that the capacitance variations will be done. With this it will be worked as your like your COM drive of type of sensor, or it can be actuator thing. So there are some advantages are there, disadvantages there, some applications also there. So these are the some of your very micro level your electrostatic actuators. In thermal actuation thing, it is made up of your two ends, one is your thinner one and another is your thicker one. So if I am fixed one, this thermal BIMOF, if I am putting fixed one, in this case, if I am providing some voltage to this one, and with the voltage if it is hitting this one, so you know the thinner one will be heated early. So in that case it is going to band it. So it is just a simulation of this thing it is done. So it is going to band it. With that also, so with the bending it is going to give you some actuation or some push or some movable things it will do. There are so many applications also there, robotics applications mainly. So some more thermal actuations application also there, that is your the symmetric or chevron type of thing. Okay, and this is coming to your magnetic actuators. This magnetic thing also, just like your just like your this electrostatic thing, it is also doing the bending thing. If you will see this bending type of thing, it is done. And what is that? Displacement due to interaction among the various magnetic elements, just like your permanent magnet, external magnetic field, and magnetizable material and current carrying conducts. With this, how it is working, that's why it is nothing but called as the magnetic actuators. So if you will see the combination of your this picture is nothing but your, so one is your one of the terminal exciting coil will be there. So this one is the exciting coil, then exciting, so this coil also there. Okay, so this is your terminal exciting coil, and these are the exciting coils are there. If you will see this yellow colors are there. Okay, then it is your because of this thing, because of the excitation of this thing, when we are providing some voltage to the exciting coils, during that thing it is generating some magnetic thing, magnetic force, and because of that the free floating or free floating end, this is going to be attracted towards the fixed point. Okay, so that is the side view of your microactuator is there. Now this magnetic actuators, they are used in mainly the robotic applications. Okay, so this one is interesting one, the SMA, the SAP memory alloy. Why this is interesting? Because this one is the interest for metallurgy peoples, mechanical people, and electronics and electrical people also. What is that thing? In this case, if you will see, there is one wire is there. If you will see, there is one wire is there, that coil type of wire is there. Now, this wire is nothing but called as the memory alloy. Memory alloy means at a normal, if you will heat it at some certain temperature, with that it is going to memorize a shape. Like I am saying that at 40 degree, at the 40 degree centigrade, it is memorizing of your this thing, like angle type of 90 degree. But whenever you are coming to your 25 degree centigrade, it will be just like straight one. So what will happen? Suppose at normal temperature 25 degree centigrade, it will just like keep it in like this thing. But simple, you just whenever you are providing this 40 degree centigrade to this the same shape, it is going to bend. So in this case, what is happening? Just like think of this. This is the straight line is there, and at some temperature, it is just bending this thing. Okay, it is just bending this thing. With that, it is opening the box. People see, the once SMA is annealed at certain temperature, this alloy can obtain the memory of shape. So at room temperature, SMA is easy to deform by small trace and deformations in plastic. So at the however the deformed SMA can recover the shape to the memorized one when it is heated up to the certain transition temperature. Just like I have given you two examples. So you can give any of the temperature for memorizing what shape. Okay, with that it is going to. So there are some application advantage and disadvantages also there. Now it is coming to piezoelectric actuator, the main area of focus. All of us know the piezoelectricity. If not known also, then it is just like the all of us know that piezoelectric materials. Okay, so the piezoelectric materials, it is nothing but consist of your two type of thing, that is your direct piezoelectric effect and converse or the reverse piezoelectric effect is there. If you will see, there is one example is there. So this is one of the piezoelectric principle is there. Like this is the piezo material. This is the piezo material is there. In this case, so a normal shape will be there. Think of that normal shape is this one. When I am providing some pressure to this one, it is compressing. With the compression, if you will see in that voltage meter, it is deflecting. That means when I am providing some pressure to the piezoelectric material, that time it is generating some voltage. This one is nothing but called as the direct piezoelectric effect. And another thing is, if this is working, then other way around is, if I will apply some electric potential to this, then it is going to change the shape of that substrate or that piezoelectric material. That is nothing but called as the indirect piezoelectric effect. That means if you are providing force and generating some voltage, that is your direct, and if you are providing some voltage and it is displacing or deforming the shape, then it is called the indirect one. So now with that I am coming to for this surface acoustic wave motors also. Okay, so this direct and indirect already told you, direct and converse piezoelectric effect. For this one, for generating this thing, what we require? We require some materials, that is your lithium niobate, lithium tantalate, langasite, quartz, layer structure material. Then they have some stability issues. Okay, if I'm using for a prolonged time or a aging stability, it is coming. Okay, if you are using for a longer period, then the piezoelectric effect also used to reduce or degrade. Then thermal depolarization, if the device is heated with a temperature just like this lithium niobate, in this case it is the 375 degree centigrade is nothing but the Curie temperature. If I am heating more than this, then the piezoelectric effect will be gone, like it will be omitted or it is going to fade away. So in that case, that is the thermal depolation. Just like that, electric depolation, how much extreme reverse electric field we can apply for them. Then it is coming to mechanical depolation, how much extreme stress we can give. Okay, so these are the issues are there when deciding the piezoelectricity. Okay, so with that I have started. So this is one of the my student, master student. He has got the certificate now, means graduated now, and he was working on the micro lens actuators. Okay, in this case, if you will see, this is the micro lens is there, and I want to move it in rotating this either this direction or this direction. So for that we have designed one special type of actuator here, combination of your piezoelectric plates with various type of thing. So in this case, just like see, if you will see, so just the simulation part of it is showing. So with this it is showing the longitudinal mode of the actuator, that means how much degree it is going to move it. So we have tried to move it up to see, this is nothing but the bending. You, this is the the simulation way it is showing bending thing. It is in reality it is not the bending thing. It is instead of like it is making the motion, like making motion, how much degree it is moving, like some of the 8 degree we want, 8 degree we want to move, that is the maximum thing we can. So for that there is the movement of actuator teeth, how much actuator teeth it is moving, if you will see x component, and what is the movement if in y component it is making. With that, what is the, with that how much this lens it is moving. Okay, so whether it is making the elliptical path or not. So now this is satisfactory because it is making the elliptical path. That means when this one, this actuator tip, it is moving and coming back, no, so that should be making some elliptical path. If not making, then it is going to damage the lens thing. So that's why it is satisfying that yes, it is making the elliptical path. So one more thing is, if you will see the micro lens only, but it is another way of, that is the single actuator it has used. In this case we have used the double actuator, and in this case the lens is able to make it angular motion, or the this is making, if you will see the simulation thing, how it is making motion. Okay, so with that it is showing the displacement of cylinder and some of the stress thing. Okay, these are necessary for deciding whether our device is functioning well or not. Okay, so another one application of this piezoelectric thing is nothing but the haptic, to enhance the touch experience. So enables virtual reality, weight illusion based on fingertip deformation, sensory motor enhancer, improve the tactile sensitivity in human fingertip. So why I am showing this one? Because this one also made by one of the student. So this is one of the actuator, that haptic thing it is going to be used. What is the haptic? Means at the fingertip only it is going to be used with this. Think of, you have seen, no, like some robots they are making. Just I will make motion of my finger like this thing, and with that the robot also able to make it that thing. So this is nothing but the this tip, these things I will be attached with my fingers, and with this, see, if you will see, this is the motion it is able to make it. Okay, so the actuator I have moved this thing. Okay, so able to make the this type of motion. What it will do, this is going to move some loads along with this thing, or suppose one fixed type of load will be kept also, then it is going to push it, then it is going to push it this side, or this side, means straight one only, this will be push either side of this thing. So these are the some of the graph for the x displacement, how it is making the displacement, how much maximum it is going to displace. If you will see 0.6 to minus 0.6 at the that is the on average, it is mm it is making the displacement. That means this side, if you will see, up to 0.6 mm to this side 0.6 mm it is going to make it, plus and minus thing. Okay. Then another person also worked on the ultrasonic actuator. This one will be mainly used for your biomedical applications. Okay, So in this case, if you will see, this is the ultrasonic actuator. There are the starter design is there. So these are the starters. Starters means piezoelectric materials only, bars, piezoelectrical bars are there. On that rotor will be there. Okay. So this one going to make motion with the if we are applying, suppose this one will be 2 will be positive, then 2 will be negative, then this 2 will be positive and these 2 will be negative. So like plus minus, if I am applying the voltage, it is going to deform in such a way that the rotor it will move, the rotor it will move. How it will be? If you will see, that is one of the meshing structure of the USM. We have done some frequency and the frequency domain and time dependent analysis thing. So if you will see how it is moving, it will be of interesting. Why I am showing this GIF type of pictures? Because see, that technically if you are going inside with one of my lectures, then it will quite difficult. Okay. So instead that you just create or generate some interest in that, and then only we can discuss more about that, whether you can work it or you cannot work, whether you are interested in working in this thing or not. So now if you will see, this is a surface displacement of the ultrasonic motor, how it is making the motion. See, only these things are actuating, or this thing are just at their place only they are staying and they are vibrating. With that it can able to rotate. So if you can see this rotation part. Okay. So as if you see, the out of scope it is doing, out of scope means the boundary whatever there is there, the shaft is going outside that thing. That's why we have used one ring here. If you see, one ring we have used, and this is nothing but making the motion at the stable position. Okay. In this case also the rotation path I am checking, yes, they are meeting with this thing. Then there are so many total displacement, velocity, acceleration, those things are there. Now I am coming to that interdigital transducer part. Okay. Here basically why I am looking to this one, this IDT, because what of the my IEEE paper is there, or the Springer and Elsevier papers are there. Okay. Recently also I have got one paper published, so that is also based on this this motor thing. Okay. So basically the interdigital transducers, they are the COM type of structure is there. Okay. And in this case, if you will see, I am just discussing about this IDT. So if I will say plus type of thing voltage supply, minus, that means if I am using some voltage supply to this thing, in that case these things will be treated as the capacity plates. Okay. And if you will see, there is a lambda wavelength is there, and how much area it is covering, just like your capacitance thing, how much area it is covering, that is called as the aperture. Okay. And the gap between the empty space and the electrode is in the pitch. So in this case I am generating some frequency thing, some range of frequency it is generating when I am applying some voltage thing. That frequency is depending on the velocity of the material. Okay. And your wavelength thing. Okay. And your wavelength thing. Now the resonance frequency f0 equal to V by lambda. Okay. Okay. So this is the pair of COM. So what it will do, if I am providing some supply to this one, that time it is going to generate that the saw velocity or surface acoustic wave it is going to generate. How it is making? If you will see, with the application of the voltage thing, that will be generating a wave like this thing, how it is moving in this GIF file. That type wave will be generated on the substrate surface, or the substrate surface, it is generating this type of wave. So now that is nothing but called the Rayleigh wave. So that wave consists of your surface normal components and surface parallel components. That means it is consist of your normal components as well as your parallel components. So with this, it is nothing but making this type of wave it is making. Okay. Just one picture it is given, how it is making the wave, and this GIF wave, how it is going to displace. Okay. So this is the technicality, like how the projection it is done, how the wave it is making, whether it is moving. No, it is not moving. At one place only the particles or positions, okay, they are just making an elliptical motion at their place. So suppose think of that this is one of the particle at they one portion only the elliptical motion they are making. So with this it is generating the relief wave. What is the application this thing? If you will see, the application is we can, so this is the one of the piezoelectric surface is there or piezoelectric wafer is there. With that we are putting this electrodes, okay, this electrodes we are putting, and this is nothing but the combination of everything, it is making a delay line. Just like that it is one port SAW resonator, the two port SAW resonator, these are the devices with the outcome, okay. And what we will do, think of that delay line means, so here it is nothing but you are providing this voltage thing, and with that it is generating some wave here. Now if you will place some obstacle or something here, it can be treated as the sensor part. Like suppose I want to detect some carbon dioxide sensor thing. Now what I will do in this case, I will use one gas chamber, I will make one gas chamber here, okay. And in that case here what I will use a chemical which is going to attract only carbon dioxide molecules. Now once that chemical I will put it here and I am generating this wave thing, I know some means with this I can able to know that suppose this 10 megahertz frequency it is generating, okay. So the frequency is nothing but your 10 megahertz it is generating. Now once this carbon dioxide gas it is coming into here, that time there will be some weight included or involved in this thing. Because of the weight thing, that frequency is going to go down or degrade. That means suppose like 10 CO2 particles it is came, so they are attached to this area thing. With that it is going to go down with the around 8 megahertz, like 2 megahertz thing it is going down. Like that I can able to quantize like in a specific air how much carbon dioxide is there. So that is one of the application, that is the sensor application. Now second thing is, suppose here I will put one obstacle here. Now with this one if I can able to move it, then it is going to move this side or this side thing, okay. So with this it can be used as the actuator thing. So this is nothing but the fundamental of this SAW devices, how we are going to use. So just like that this resonators also we can able to communicate or transmit the signals. Now how we will know that resonators whether it is working well or not? We need to simulate them, or if we are fabricated then we need to test them. So in this case I have taken one port SAW resonator thing. In this case taken the what is the aperture is there, okay, then what is the resonance frequency it is giving and what is the anti-resonance frequency. That means here this is giving the maximum displacement and in this case it is the minimum displacement, just like in two frequencies you can say it. So that is just like your what is the total displacement is occurred and what is the admittance. In admittance is nothing but made up of your conductance and susceptance thing, okay. So if you can check it, the simulation of the delay line thing, in this case delay line it is moving in this direction. So basically this is the GIF, okay, it is not working fine. So okay, now the application as a SAW motor or surface acoustic wave motor is, just I told you this is my total device, and in that case one slider I will be putting, slider means one obstacle I am putting here, and when I am providing this input power supply it is going to move or it is going to displace this thing, okay. So that is fundamental bit. So it is developed in Japan, okay. Now if you will see the total device is here, the total device is this much, if you see the total device is this much, but to make it functional it is taking a huge assembly. Now what I decided, I need to remove of the assembly thing and make it a commercialized product. So for that I changed the orientation things and worked on this thing, okay, and found that okay this type of your device will be working well and functional. Like two starters I will be using, piezoelectric substrate you will be using, and we are sandwiching with a slider inside, and with that it is working well. So if you will check it, I have started with working whether one side also working or not, whether it is functioning or not. For that also you have simulated and optimized that yes, it can work well. Okay. So basically I have worked on previous paper, previous published paper, and I added some materials, I added some other parameters, and I got well result out of that. Okay. So just like optimizing and preload coefficient of the friction, this one you will be getting the output of this work. Okay. Now so on the, again another work also we have worked the single side only, but in this case we have used some projections. Okay, projections means this is the obstacle which is moving, but on that obstacle if I am using a plain one, okay, so there is a the friction will be high. Because of that, the displacement will be very less, but if I am providing some projections, then it is moving smoothly. So just a small motion or some small simulation picture it is added at time t, it is at this place, and with some displaced one with after some time, then it is displayed with this thing. This is the simulated one. Actually these things are GIFs, it should be showing, it should be, otherwise I will show you some other pictures also, other videos also. So now if you will see, so everywhere here onwards if you will see the outcome of every work, outcome means in terms of your papers or patents or conference or journal papers. So here below thing you can mark it. Okay. So like that, and again this is one of the work, just I am comparing two things, like whether it is the projected one is working well or the plain one it is working well. For that also we have got this thing. So basically if you will see, the projected one is the displacement is high at the same time as compared to the displacement of a slider without projections, like plain one. I told you in this case the friction is playing a big role. That means a huge contribution of the friction, because of that it is not moving. So now we will be working on this thing, double sided thing. In double sided, what is that? So both the side it is going to give the actuation thing, both the side it is giving force to this one, both the sides, and because of that the slider is going to move. So the direction why it is given in this direction is because the elliptical motions, if you will see, if this side actuated, okay, if this side actuated, then elliptical motion is this one, like this one. So what is that thing? At this the force will be high, because see, if you will see in the elliptical motion also both arrows are there, at the top side also arrow is there, at bottom side also arrow is there. Okay. So in this case at the top side you will be finding that the force will be high, and at the bottom side you will be see that force will be less thing. Okay, just a minute. Okay. So now out of that we have got this transaction thing. In this case, just like your the starter, two starters we have used, and with this it is going to move this thing. So many results it is there. I am just showing the techniques, I mean technical things, how it is making the motion thing only. So in this case we will be we will be finding out whether how much displacement it is doing, how much velocity is giving, how much stress we are putting, because these things. So where we will be using, in this case we can able to move the printer heads. Okay, the printer heads are very micro level thing. Okay, in that case if I am using this one, this can be used for making this printer heads. Some micro mirrors also we can able to displace if I am providing this some output side. So this will be micro mirrors I will be putting, so they can able to tilt, this thing. So this is also one of the keyword type of projection. Okay. Okay, here you can see it. Here you can see the conventional saw wave. Okay, in this case how much it is taking. Okay, means how much time. See, both the things it is moving here for your for observation. You just check it. this is the single side, which is conventional one device was there. The slider is moving, but it is very slow. Okay, but in this case it is moving, it is quite faster thing. Okay. Now with that we need the control also, like left to right or front to back. If I have used a square type of your starter, in this case you can able, if you are fabricating some 4 side IDTs also there, then you can able to move front and back thing and left to right thing. So for that we have used the, we have designed the control thing also, how you are going to control the switch, means the switches will be used. It is a simple switch have used, but in this case we need to apply so many other devices also there. So for a smooth movement of the slider thing. Now we thought of that, if this one, if this slider it is moving, okay, then instead of that, if I will put a cylindrical shaft thing, whether it can make us a rotational one or not. But see, in this case it can easily it can move this left to right, but I am just deciding that whether it is going to make this type of rotation or not, either either clockwise or anti-clockwise. Then we tried working on that. Okay, finally we are able to, yes, here finally we are able to see that, okay, this is the linear displacement, it is fine, it is working. That means it is moving the linear way in the x direction, in the x axis only. So either the left side or right side thing, the tangential displacement is given and the velocity it is given. So smallly it is going to saturated at some place. So with this we have okay, so these are the works. Okay, just a minute, because power down. Okay, so like that we have done for the rotational one. Yes, we were successful, like the shaft was working in the clockwise and anti-clockwise direction. Even with that we got that paper also in IEEE paper. Okay, for that also we have designed the control thing. Okay, so in this control it can able to make the clockwise rotation and anti-clockwise rotation. With the switches, the selection of switches, it is going to give us the result. Okay, so this is the fabrication process. Take the piezoelectric substrate, then we are coating with this photoresist, then we are putting this UV photolithography thing, and aluminum deposition. Finally we can able to get this the delay line thing. This is the one device. After that you can able to do the wire bonding, and with that you can able to get that device finally. So these are the processes which I have done at IIC Bangalore, the fabrications thing, everything I have done. So we have taken the piezoelectric substrate. With that finally we got the device. Just like that, the slider is there. In the slider thing, if we have taken the silicon and we need the thicker one silicon, that's why we have bonded 2 silicons. Then we gone for the photoresist coating, then UV photolithography of the cylindrical projections, then finally this will be the final device thing. Okay, so this is the fabrication process flow for the slider. Okay, so these are the, so I told you that wire bonding, so that if you will see, these small wires are connected with the this patches, okay, where the connecting things are there. So if you will see, in a single wafer only we can able to produce different dimension of 3 devices, 3 delay lines. Okay, once we are splitting them, okay, and we can able to get the devices in our hand. Now this is the setup for testing. So we have applied, because see, what are the things we have designed at the how much frequency it is going to give us, the resonance frequency. But when we are testing, that time you will, because of some lack of this your designing method, or with some fault, you will be getting some difference in the frequency, the resonance frequency of the final device. That's why you need to design some of the circuits also, and with that we can able to do the practical thing. So okay, okay, it is working. Just it is not moving. Just a minute. Okay. So it is visible to all of you? Yes. Please respond.
Yes.
Yes.
Sir.
So yeah,
Sir,
yes.
visible.
Just
Yes,
see
sir.
this.
Visible, sir. Visible, sir.
Yeah. Just see the picture. This is the video.
Yes, sir. Video also visible, sir.
Okay. So if you will see, there is a bit is there. Okay. So we have applied. Just a minute. So we have applied the voltage supply to here. So through this wires are there. Okay. So this is the silver coatings are there. Okay. So with that we are using the connections, and if you will see one bit we have used here, a particle we have used here to see whether our device it is working or not. So for that we have okay, for that we have gone for this one. So if you will see, so this is how it is making a rotation type of thing. So like that, if we will come to our double sided thing, in this case if you will see this is one of the slider thing which is going to work. Okay, so for a very small time it is using, but after this also, because what are the videos we have captured with the digital camera, what are the videos we have captured, just I am showing you. See, this is for a longer period thing, just like that. If you will see, this is a hollow type of thing, a hollow type of slider we are using, and it can able to move. Okay, so these are the things are there. Now if I will see, okay, again, so these are the two patents were applied, and even one is granted here just now, just 15 days back only it is granted here. So one of the Indian patent, and okay, this is the latest paper I received from the elsewhere thing. Okay, with the liquid thing we have tried, those are the some of the dry thing we have used, and this is one of the liquid thing we have used, and with that we are able to get this paper. Okay. So there are so many applications are there. If you will be interested, then you can work on this. Okay. So these are the some of the pictures I kept for you, for interesting thing. That's why I have started with some of the basic. If I will conclude here, I have started with very basic thing. Then how the revenue is there, what are the different divisions are there, how we are segregating the things. Then it is coming to the sensors, how it is working, the actuators, then specific to some of the actuators, then finally the piezoelectric actuator. So this is the thing. So here I will stop my talk here. If anything anybody want to ask, please go ahead.
Participants can unmute yourself and you can ask your doubts. Sir, one small, this one from our side. Actually, like for students level, for BE students, what type of work we can give in this area, sir, if they are
Okay.
like any projects or small.
Yes, yes. Basically, see, in case of you just MTech students, I have shown you some of the 3 examples now. Those were done by the MTech students. Like now, so just I'm coming to that one. So the intensity should be less. Like in case of a BTech thing, they should just give them one research paper to only to regenerate that result, nothing else. Regenerate that result, and if they are able to regenerate that thing, just a small modification, just think of that one cylindrical just a cantilever only, they need to make it a cantilever. So in that cantilever only, suppose they are putting some chemical coatings, it is not a bigger prospect, I am not saying, a smaller thing, only is putting some chemicals, and what is the deformation they are able to see, that's all, that is fine.
Okay, sir. Okay, sir.
Sir, good afternoon, sir.
Good afternoon, sir.
Sir, what is the basic infra is required to set up this MEMS lab, sir?
No, sir, actually this MEMS lab is too costly.
Too
MEMS
costly.
lab is too costly, yes. But thing is, if we will use some simulation tools, just like console, ANSYS, those things, no, uh,
Hmm.
they are able to provide us the student version also, okay? Because
Hmm.
MEMS lab is very costly, that's why only ISC Bangalore and
Ah.
IIT Bombay and Guwahati also got that thing.
Oh,
Like some days back only, they got some like 62 crores
oh my
from
God.
tech. Yes, because I'm also trying my best to set up a small laboratory in NIT Jamshedpur, but
Okay.
getting the funding is very difficult, sir, very difficult.
Okay, okay. Actually, we are also plan to do apart from the curriculum some lab setups for the UG and PG level of students, sir. We listed some labs, sir. In that
Hmm.
MEMS also we plan to do, but your answer is difficult. Really, it's very difficult to get funding for these labs. I think so, sir.
Sir, even one, if you will go for only one component, see, I'm saying that in that lab where the IIT Guwahati they got the funding, there I was working as the SRF. So for what
Oh,
purpose? To set up the lab. I was handling 2 to 3 equipments. Each equipment was costing around 3 crores.
oh my. Okay, okay.
So that
Sir,
is quite sir, please.
sir, if any possible to do based on the consultancies are like a center of excellence like this, the
Hmm.
MEMS industry we can be take like as tie up with the academic institution and possible to do, sir.
Yes, yes, that is fine. That is fine. Even the solid state devices lab can be done. In that case, only small components are there. Hardly with 40 to 50 lakhs, you can able to set up 40 to 50 lakhs. But in this case,
Okay,
very limited work you will do.
okay, okay, okay. So far, wide range of research work we difficult to take, I think so.
Yes, but see, another thing is, sir, ISC Bangalore is giving a huge scope, sir, for everyone under the
Okay,
INUP program, India's Nano User Program,
okay.
INUP. Okay, sir.
INUEP. Ah.
INUP.
Okay, sir. Okay. I will check it this also, sir. Then, if it is any possible to do some design or some research work in this lab, we will definitely will do that. So, okay, sir. This is only the main thing. But your presentation was very nice, sir. Very informative, and lot of informations you given. And we are having a lot of gap between MEMS and our curriculum, sir. Actually, MEMS, one of the elective subject in our Vishwesvaraya Technological University. So
Okay.
this kind of lot of research work, if it is there, they can be make this subject like as a core for our electrical engineering. So definitely, I am also one of the BOE member in the VTO. So once I will be take this information to the registrar level and try to bring this MEMS subject in the core area, sir.
Yes, sir.
Thank you,
Thank
sir.
you, sir. Thank you for
Sir,
that.
you accepted and you are supported us. Thank you very much. Really, we feel very happy. So, like young professors like you all can join and support to us. Still, we can do lot of wonders in this students' society, sir. So, to the student society. Once if we can come to Bangalore, you compulsory have to visit to our college and you have to visit to our faculty and students. On the day, one special guest lecture I will be arranged to my students, and I will be take you to the management, and I will be introduce such a faculty as giving good support. Like I will be honored to you, sir. That is pleasure to us to honor you, sir.
Thank you, sir. Thank you
Sir,
for
thank
that.
you very much. Dear participants, do you have any questions? You can interact with the resource person. This is the opportunity to interact with the resource people. Please kindly come forward to ask some questions. Jay Kumar sir,
Hello, sir. Participants can unmute yourself and you can ask your doubts.
doubts.
Basically, sir, with limited time,
Yes, sir.
with the limited time, they are able to consummate, digest it, get some question to be, that is a very tricky thing, sir.
I'll agree with you, sir. I'll agree with you. But some people definitely some resource people will be there. Sometimes they can ask, but we should give the permission to the forum also, sir. So that I asked. Okay. So
Sure, sir. I will
thank
be
you
there,
very much,
sir.
sir.
Yes, sir. Yes, sir. Yes, sir.
Thank you very much, sir, with your informative and very effective session. Once again, I will call the coordinators to conclude the
Yes,
session.
sir. 1 minute. Thanks for the wonderful session, sir. Now I request Professor Manjushri, Assistant Professor, Department of EEE, to deliver the vote of thanks.
A very good afternoon to one and all. It's my great honor and privilege to propose a vote of thanks on this occasion. On behalf of the Oxford College of Engineering, I, Manjushri, Assistant Professor, Department of History, take the opportunity to propose a vote of thanks to all the distinguished present here. First of all, I would like to thank our speaker, Dr. Basudeba sir, for excellent presentation. Thank you, sir, for accepting our invitation. Sir, I would like to thank the chairman, directors, principal for their support and guidance. I also wish to express my thanks to our HOD sir, Dr. Bharat sir, for encouraging us and supporting us. Special thanks for Professor Jaitma sir, Dr. Devi ma'am, and all the teaching and staff of the department for the support and making the FDP a grand success. We are happy to express our thanks to all the participants also for being with us throughout the session. Once again, I thank each and everyone. Thank you, sir.
Thank you, ma'am. Thank you, Basudeba Behera, sir. Thank you very much. You are very kind of you. Accepted our request and delivered a very nice session to our students and research scholars. Thank you very much, sir. Once again, behalf of everyone, I thank to you, sir. God bless you. Thank you very much, sir. Thank you, sir.